Hi scholars, and welcome to the final semester of your SEO Core Math curriculum. We've come a long way, right? And during your first semester when you guys were in ninth grade, we learned about numbers and operations, reviewed a lot of middle school material. You reviewed over the summer linear and quadratic functions, relationships, how to model with them. You learned in the fall of your 10th grade year about percent change, exponential growth, working with exponents algebraically, solving radical equations. The spring of your 10th grade year, you learned how to solve rational equations, work with unit rates, do a little bit of unit conversion, function notation, how to shift graphs, transform graphs. You even spent a couple lessons learning about the derivative, beautiful concept. In the summer, we learned trigonometry and statistics, and now your fall 11th grade year, you guys are ready to tackle the SAT, right? So this semester and these homework help videos are really all about sort of getting you guys to use the material that you already know, the concepts that you already are familiar with, and apply them in SAT type questions, right? So it's not a test prep class per se. We're not going to be teaching you strategies about what to do in multiple choice type questions. You'll get that a little later, but it really is still grounded in the math, right? So first thing we want to do is give you guys an idea of one way that you can look at a solution sort of strategy, right? Lots of times on the SAT, you're going to see questions that have a lot of words. They're very dense, and just like in ELA class, it's going to be your goal is to unpack these questions, right? And so here's sort of a procedure that you can use that could help you instead of just staring at a question and say, I don't even know where to begin. Well, here's where to begin, right? So the first thing you want to do is annotate. You guys have been doing this in ELA class, and basically you read the question, and any information that you think might matter, just draw a line under it to sort of highlight it. Not all information is going to matter. There could be some distractors in the questions, but first pass, underline things you think is going to matter. And then whatever you're asked to do, just put a box around it or mark it in some way. You could circle it, however you want to do it, just to keep your eye on the prize, what the question's asking you to do. A lot of times you're going to be doing beautiful math, and you get to the very end, and then you say x equals 6, and then you say that's my final answer, and then the question is saying what's the value of x plus 1, right? So you do all the correct math, but then you don't answer the question, right? X plus 1, if x is 6, x plus 1 would be 7, right? Would be the right answer there. So you always want to make sure you have an idea about what you're doing. So this is a good way of sort of orienting yourself. Step 1, you're oriented to the problem. Step 2, summarize. So in your own words, what is this all about? Now, you don't have to spend the time to actually on a test to actually write it out, right? That'll take some time, but you do want to think in your mind, I just read a bunch of stuff. What am I being asked? What is going on here? See if you can rewrite it in your own words. How could you describe to someone else what this problem's all about? So step 1, annotate. Step 2, summarize. And step 3 is you're going to make a plan, right? And you're going to make a plan that's based on a potential solution pathway. In other words, once you have an idea about what it's about, what you're asked for, what's important, how are you going to use what's important to get to the answer, right? So you want to create a sort of pathway and think about what steps are you going to take, right? Oftentimes, when you read a question, you might immediately skip steps 1 and 2. If you know what the big idea of the question is, you just go immediately to step 3, right? If you see this is a system of linear equations, you say, I know how to solve a system of linear equations. Boom, you're right at step 3. Okay, so once you have an idea about what path you're going to take, actually do it, right? Step 4 is to solve the problem, so follow your pathway. And you want to ask yourself, does my answer make sense, right? You always want to be asking yourself this question. Lots of times, especially when you're doing some calculations, it's easy to, if you forget a negative sign or something like this, right? The entire problem could go all wonky on you. And so you always want to ask yourself, does my answer reasonable? And so step 5 is going to be to check your work, right? Does your solution make sense? And so oftentimes this could require you putting the answer, plugging it back into the problem and seeing if the numbers work out. Lots of times this check is really just about you reasoning through it. Could this answer be a possible answer? Sometimes you can do it sort of in your mind, all mental arithmetic or mental math. So while you're going through these steps, this is a nice way to sort of think about them. During this course, it's important for you to practice doing these steps, and then once you get good at them, right? They get ingrained, and you don't have to go back and say what were those 5 steps again, right? Annotate, summarize, plan, solve, and check. Once you get used to them, then you can sort of move a little quicker through some of these problems. All right. So that's sort of like an overall strategy, but here there are a couple of questions that you might want to ask yourself in particular problems. And these are called heuristic strategies, right? This is the word, is H-E-U-R, heuristic strategies. And these are questions you can ask yourself that'll help you get unstuck. Does this problem look familiar, right? So have you seen any problems like this before? Oftentimes, if you're able to access to sort of figure out what type of problem it is, then you can say, wait a minute, I do have some strategies, right? If I read a problem and I say, oh, I think this is about a linear relationship, I can think, I know if I have linear relationships, I can find the slope or I can find the y-intercept, right? So once you identify sort of the content area, oftentimes you're able to identify some possible solution strategies. All right, so the second thing is, are there any keywords in this problem that help you identify the content area? So per, right, would tell you maybe we're dealing with a proportional relationship, right? Or a unit rate relationship, right? Dollars per pound, for example, okay? Can I break the problem down into sub-problems? So oftentimes, SAT questions, they'll sort of involve one step and then another step, right? So sort of like one step to get an answer, an intermediate answer, and then that intermediate answer will help you actually get the final answer right there. And so you want to think, can I get halfway first, right? Do a sub-problem, and then from that halfway spot, how can I go? And that right there is going to also relate to your when you're planning your solution pathway. It doesn't make sense to work backwards, right? In many of these questions, you do have either you can sort of start with what you're being asked to do and sort of work backwards, and sometimes you're even given right answers, right? Answer multiple choice answers, and so if that's helpful for you to work backwards from those answers, that's okay too. What patterns do you see? Okay, math is in many ways it's a way of solidifying, of codifying patterns, of describing patterns. And so if you see any patterns, think about what that could do for you. One thing is you can or a couple things that are sort of related are, can you make the numbers easier to explore what the question is asking? Or could you substitute numbers for variables to explore what operations make sense, right? And so the idea with these two strategies is that oftentimes you may be given a problem where the numbers are very complicated or they're just ugly. You can't really do mental arithmetic in your mind with them. There'll be decimals or fractions or something like this. Well, make the numbers 2 and 3 or 2 and 5, right? To explore what the question is asking. And substituting numbers for variables is just another way that you can sort of use your reasoning, even if in the problem it looks like it's too abstract or something like that, too symbolic maybe. Does it make sense to draw a picture or a graph or map the question out in another way, right? Can you draw a representation of this question? And then finally, does your answer make sense, right? And you always want to be asking yourself, does my answer make sense? This right here is a really important question, not just for the SAT, but just in general for life, right? You always want to make sure that whatever you're doing sort of makes sense. All right, let's take a look at a couple of problems. So all the questions that we're going to see in these homework help videos are coming directly from SAT practice tests, so they're all very similar to what you are going to see on the SAT. So first off, before I even start reading, it's nice I have this equation. Looks like it's a quadratic equation if we're considering Q as a function of V, right? Because the V there is this V squared right here. So it could be a quadratic sort of relationship. And it's also linear in n, right? So if n changes, Q is changing sort of proportionally, right? Okay, so the dynamic pressure Q. So first off, I'm going to underline that because this is what the equation is all about. It's about dynamic pressure. So generated by a fluid moving with velocity v can be found using the formula above, where n is the constant density of the fluid. I'm going to underline n is constant density because this means that n is where it is right now is a constant. So we can treat it. It could be 2, it could be 5, it could be 0.7, but it's the same number, right? N is not varying, it's not changing, right? Okay. An aeronautical engineer. Notice I'm not underlining aeronautical engineer because who cares who is using the formula, right? It says not important. So an aeronautical engineer uses the formula to find the dynamic pressure of a fluid moving with velocity v and the same fluid moving with velocity 1.5 v. So already we have these two different situations with fluids. One where the velocity is v and one the velocity is 1.5 v. So a little more than the velocity of v, right? In fact, 1.5 times larger than the initial velocity of this fluid, right? So what are we asked? We're asked what is the ratio of the dynamic pressure of the faster fluid to the dynamic pressure of the slower fluid. So I'm gonna just sort of put that in a box or however you want to do it, right? This is what we're being asked to do. And so our goal is to find a ratio. So we want to find a ratio of the dynamic pressure, which is Q, right? So we want to find a ratio of Q of the faster, right? Over, right? Because ratio is sort of a comparison of two things. So over the dynamic pressure of the slower fluid, right? So this is Q of the slower fluid. Okay, so this is my goal. My goal is to find this out, is to find this answer, right? Well, what do I know? Well, I know, because I underlined it, that the faster velocity is 1.5 v. Now I could use this expression and sort of plug it in, right? I could use the slower expression and plug it in, right? But I could also, if I wanted to use one of my heuristic strategies, I could also say, can I substitute numbers for variables, right? Can I substitute numbers for variables to explore what's going on? So let's do that. Why not? Let's just try out this strategy. So for example, let's say that the initial velocity, let's say that v was equal to 2, okay? So this is v slow. I'm just going to put an s there for slow. So slower velocity, let's say it's equal to 2, whatever, 2 feet per second. Who cares, right? In that case, the v fast, the faster velocity is going to be 1.5 times the slower velocity, otherwise known as 3, right? So what we can do now is we can compare the dynamic pressure of the faster one, right? Using this formula, if we wanted to, right? Where we're plugging in, instead of velocity, we're going to plug in 3, and we could then compare it to the slower one where instead of velocity, we're going to plug in 2, right? So let's see what happens if we do that. So Q fast, I can say, is going to be equal to 1/2 of n, and our fast velocity was 3, so that'll be 3 squared. See what I'm doing? Just plugging those numbers in, and I'm comparing it. I'm finding the ratio compared to 1/2 n of 2 squared, right? And this right here, whatever this is going to be my answer. Now, of course, we want to notice that the 1/2s cancel and the n's cancel, right? So in fact, this is because when I say that, because the n's, right, is a constant number, so it doesn't really, it's not going to affect a ratio, right? If I have the same number as a product in a numerator denominator, it's not going to affect the overall ratio. And then the same thing with 1/2, right? We can say, if we wanted to, we could say that in this case, Q is, and the symbol right here looks like a fish, is proportional to, it's proportional to v squared, right? In other words, the only numbers that matter if we're dealing with this ratio is the velocity numbers, right? So now there's nothing more than saying that this is nothing more than 9, right, over 4, which is 2.25, and that's our answer. Our answer is, in fact, 2.25, or 9 over 4, okay? That's the ratio, right? Now, the ratio, of course, is not the same as the ratio of just the velocities, and that's, right? It's not 1.5, which is the ratio of the faster to the slower velocity. It's, in fact, a different number because it's related to that velocity squared, right? That's a key idea of this problem. That's why they're asking you this question. Let's say you did not want to use this strategy of plugging in, finding actual numbers, and you want to do it entirely algebraically. You could, right? You could say that, right, if I just want to go over here and just say another solution strategy, you could say that Q fast, I'm going to ignore the 1/2 n and the 1/2 n because they're going to cancel anyway, right? And I could have just kept it with 1.5V, entirely algebraically, right? I could have done this, you see? This is nothing more than, so this would be 1V squared, right? It's nothing more than plugging in the velocities. For velocity is 1.5 and velocity is just 1 of that V, right? And if I do that, I would end up with 2.25 V squared over V squared, which of course we can cancel our V squares and end up with the same answer, right? So you get the same answer in either case. Let's take a look at one more example. So in this example, we're given some information that's written in a table. This right here is a table, and in fact it is a two-way, we can call this a two-way cumulative frequency table. And the reason why we say it's two-way is because you have one way is a type of movie, it looks like, right? Is going in this direction, right? It's so sort of taking up all of the columns, right? And then the other way is the rating of these types of movies. So that's why we call it a two-way table. We just call it a two-way table. Okay, so it's a bunch of numbers, and likely, right, our answer is going to be, let's find out two numbers from here, or find out some calculation with these numbers that's going to give us our answer. Okay, let's go. The table above represents the 50 movies, so I'm going to underline 50 movies. That's all of the movies that had the greatest ticket sales in 2012. And if we want to say, let's look at this table, and where can I find the number 50? Right here, it's the total, right? It's this bottom row, or the last column, bottom row, and this is the total, right? And you can also sort of see, before we go on, how these tables are organized, right? So I have, for example, action movies. 2 of them are PG. 10 are PG-13, 6 are R, and so there are a total of 18 action movies, right? You can also go across and say there are a total of 11 movies that are PG, right? So that's how these totals work, right? We can even sort of show that the everything that's outside of this red line, these are sort of the totals, right? Where they're adding up all the numbers that are inside here. Okay. All right, so then we say categorized by movie type and Motion Picture Association of America rating. So who cares about that, right? That's filler. That's not important. Okay, what's our question? So what proportion of the movies are comedies with a PG-13 rating? So this is our question. Keyword here, if we say, what are some keywords, right? Are there any keywords? All right, well, yeah, I got a keyword. Keyword right here is proportion. That is a key word. Means our answer is going to be a proportion. So it's going to be a part to whole, right? We can call that a part to whole. This question could have been asked by saying what percentage of, right? That's also a part to whole ratio. So a proportion. So what proportion of the movies? Okay, of is going to be a keyword. Of is indicating that it's of the whole thing, right? So the movies. Well, the movies. How many movies are there up here? There's 50. All right. So already I'm starting to sort of see my strategy here. So the whole is 50. All right. And what part are comedies? Okay, I go to comedies. 9. Well, no, because it says what part are comedies with a PG-13 rating. So I have to find out of these 12 cells, which one shows me comedies. Which one shows me comedies with a PG-13 rating, right? And the answer is this one right here, which is the number 4, even though I drew over it, but number 4. So the part is 4. So the answer is 4 over 50. None of the answers are 4 over 50, but of course we can reduce that to 2 over 25. And there we go. This is our answer, right? Again, they could have asked you what percentage, right? If they said what percentage, we could have done a little 8 over 100, otherwise known as 8%. So those are the percentage of the movies that are comedies with a PG-13, or of the movies are comedies with a PG-13 rating. Have a great week.